Hello and welcome everyone. In this video I want to talk about parameters, more specifically about how to define the range of a parameter when it should not be linear. In the JUCE framework you often use the object audio processor value tree state in order to create your parameter layout. That object, however, wants you to use a so-called ranged audio parameter, which is a combination of audio parameter bool, choice, float and int, and the audio processor value tree state parameter specifically uses audio parameter float. So when we look at the arguments of audio parameter float in the constructor, we see ID, name and then range. And the range object is normalizable range float, which we have here. Before I go on, I just want to say that even if you are not working with audio processor value tree state, which could be for various reasons, you would still create a parameter object that sort of has something to do with ranges, and you would probably end up using normalizable range or a comparable self-made object anyway. So it makes sense to understand how it works. Normalizable range has a lot of constructors, and I want to specifically talk about this constructor, which takes the range start, range end, and 3 value remap functions as arguments, because it's the most powerful constructor of them all. But before going into that, I want to show you an example of how you can use this. I'm in some part of the code where I just want to drop my demonstrational code now, even though this is not the parameter creation part of the code. I want to make a parameter that starts at 5, ends at 2000 and has a center at 20. This could, for example, be an attack parameter in a compressor or release maybe, because there you want to have a lot of precision on the knob on these first values, 5 to 20 milliseconds, and then it should be a little bit more coarse towards the 2 seconds. So now we are creating a normalizable range. And our first argument is the starting point, 5, and the second argument is the end. And as you can see, this already constructs a normalizable range in one way. Now we want to know what's in the middle of this range. And we can see the center is 2002.5. I hope you can read it. If you're on a phone, that this might not be very readable, but I just read it out, 2002.5. So around 1 second. And as we defined before, we want to actually be 20 milliseconds be the center point and not 1 second. So we are pretty far off. So we use the constructor where we can actually define 3 lambdas. And every one of these lambdas wants to have a minimum argument, a maximum argument, and a third argument. In the first lambda, we have a normalized value that we want to convert to a denormalized value. At the moment, I just return the normalized value. Then the second lambda has a denormalized value and wants to normalize it. And the third lambda has a denormalized value and wants to legalize it. So as you can see, this also constructs a range, but at this point nothing changed at all. Let's start with the function that legalizes a value. That is actually pretty easy. You just say, is the denormalized value smaller than the minimum value? Then it's the minimum value. Else the denormalized value is bigger than the maximum value, then it's the maximum value, else it is the denormalized value. Just in order to make that a little bit shorter, let's call it X. Now we already nailed this one. Let's also write something for the other ones. In order to do that, let's actually dive over to Desmos so that we can have something where we can prototype a little bit better. And here I actually now want to use this nice little feature where I can create parameters for start and end. And of course now the range defined by end minus start because it shows the length of the parameter. Now we can ask ourselves, how can we make a skewed value? Without even considering the range, we know that we can just make a parabola to make sort of a curved shape around 0 to 1. And we know that it gets curvier and curvier the more we turn up this number. So we try to generalize that. Now I created a parameter called b, and the more you turn it up, the more you get a curved shape between 0 and 1. Now we need to actually scale it up to the range, which is easy, just multiply it with the range and add the start. Now this is the function that denormalizes our value. So we can now just write it down in here. Now you probably noticed that we don't have a bias value in here yet, so let's define one. Now we actually need a denormalization function that sort of undoes whatever this method does. So now we just have to think backwards. The first thing that we want to get rid of is the starting offset. So we say minus start. And then the second thing that we want to get rid of is the range. Now we just have to deal with this parabola stuff, and that just happens to be this formula. And we can test that now by just plugging in a value. Say we have a denormalized value of 2, and that yields a value of 0.8 or something. So now we have a normalized value of 0.8. And it yields a value of 2. So it can get back and forth and convert these things from normalized to denormalized and from denormalized to normalized. Let's actually give this a test run. Now we can see we get a lot closer to our desired value. Let's try a different value. Okay, 24.95, pretty close. 21.1595. Okay, so obviously that is not our desired end value 20 yet, but you could get close with experimentation. Also, these shapes are not perfect or even close to perfect in general yet. They have a different shape at the start than they have at the end. So you can actually experiment with different bias functions. And as long as the normalization function matches the denormalization function, you should get valid results. And then you just have to come up with something that works for your parameters. If you go on my GitHub page, click on Project, Source, Architecture, and then Range, you find the namespace where I provide different methods to construct ranges. One of them is called Biased. And if you look at its Desmos page, you can see it is not only a cleaner bias function than the other one, but it also goes into both directions and even provides a solution for no biasing at all. So you can basically use it for all of your parameters unless you need something that is really more specific. I have to give a shout out to the developer Signalsmith who came up with this function. So I basically just took it and reused it for my own purposes. Signalsmith always comes up with very useful DSP stuff, and you should check out his stuff. Signalsmith also has a page with a lot of tutorials for different DSP problems. Now I want you to go out there and make your parameters better with normalizable range.